Hello everyone, welcome to question number 3 of advanced question series on parabola. Our today's question is prove that two parabolas y square is equal to 4ax and y square is equal to 4c into x minus b cannot have a common normal other than x's unless this condition holds. The condition is b upon a minus c should be greater than 2. We have to prove this condition. So let's start with y square is equal to 4ax. So as usual the vertex will be at origin. Now for the second parabola y square is equal to 4c into x minus b. As you can see, the vertex coordinates will be y coordinate will be obviously 0 and x coordinate will be at what value of x, y will be 0, I think at b. So depending on b where it's having its vertex, okay, it can be positive, it can be negative, but the axis will be same shared by both of the parabolas. Axis will be x-axis only. So let me draw the two parabolas. The two parabolas will be like something like this here. For the first parabola, vertex is origin and it will be something like this. Now let's say the second parabola is something like this. If b is positive, I'm taking this. You can take on the other side, there's no problem at all. Now let's consider they share a common normal other than axis. So other than axis, this is the common normal as you can see. Let's say one more normal they share, something like this. And this is our normal. So we have to find this condition that if b upon a minus c is greater than 2, unless this condition, they cannot have a common normal. Okay, if this condition holds, we have to prove. So I'm going to write the equation of normal. Equation of normal to first parabola to y square is equal to 4ax and y square is equal to 4c into x minus b. So for the first, I think for the first parabola, if the let's say the slope of the normal is m of n or m of n or m only, the equation of the normal will be y is equal to mx minus 2am minus am cube. And I think this slope form all of you remember. Now for the second parabola, we can do one thing. Instead of these two, if you compare these two equations, instead of x only the change is x minus b is there, and only one more change is there, that is instead of a we have c here. So you're going to do one thing in this given equation, दुनिया में जहाँ जहाँ x है, we're going to replace x by x minus b. So we'll get this as m into x minus b minus 2cm minus, here you'll get this as cm cube. So this will be the equation of normal. Let's say this is first equation and this second equation. Now I'm going to compare these two equations. So comparing 1 and 2. So if we compare 1 and 2, you will get coefficient of y upon coefficient of y is equal to coefficient of x is I think m. In the first equation, coefficient of x is m again, will be equal to the coefficient of the constant value. The constant value for the first equation of normal is minus 2am minus am cube, whole thing divided by, you will get this as minus mb minus 2cm minus cm cube. Now easily you can compare the first here, the first component and the last component. So I'm going to compare these two values in the next slide. So here I'm going to compare first and last. So that means the whole value, these two values are equal as it is. And I'm going to remove the negative, 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 and negative, negative from here. So we'll get this as 2am plus am cube is equal to mb plus 2cm plus cm square or cube, sorry. So from here, I think m and m will cancel out. The remaining is 2a plus am square is equal to b plus 2c plus cm square here. Now I'm going to calculate the value of m square. So let's collect the coefficient of m square, that is a minus c multiplied by m square is equal to b plus 2c minus 2a. So from here, m square is equal to b plus, I think I can take here 2 common, that is c minus a, or with a negative I can write this as minus times, if I take 2 common, then we'll get a minus c here, and whole thing is divided by a minus c. Now this is the value of m square. Now here we are getting a cubic and we have cancelled m here. Then that means if I don't consider m is equal to 0, let's say if I consider m is equal to 0, then that means the solution is axis. If m is equal to 0, then the normal will be common normal will be x-axis, and they are saying they cannot have a common normal other than axis. So they are asking other than axis. So if m is not equal to 0, I can cancel m here, there's no problem. Let's calculate the value of m. So if m square is positive, that means we'll have more than one normal other than axis. So let's take m square positive. So the value of m square is, I've written here, I can write this as b minus b upon a minus c, and then here I can divide individually and I can write minus 2 is greater than 0. So if m square will be positive, then that means we'll get two values of m. That means we'll get b upon a minus c is greater than 2. Only on this condition we'll have more than one common normal. Okay, that is other than axis. So I think we have proved our part, hence proved, and that'll be all.